Behind me you can see the Illgraben catchment, which is our study site. The Illgraben catchment is a very active catchment on debris flow events.
Debris flows are complex mixtures of water, fragmented rock and sediments of all sizes. As you can see, they can be very destructive because of their high sediment concentrations and mobility. Illgraben is one of the most active mass wasting sites in the European Alps, with more than 5 debris flows and sediment transporting floods per year. Most of the events are rather small or medium, with volumes smaller than 100,000 cubic meters. The Swiss Federal Institute WSL has been studying the debris flows in Illgraben for the past few years. Whenever there is a debris flow, we measure the fluid pressure, the speed, the weight, and also how high the flow gets. Yet, most of these measurements take place in the lower part of the channel because they require a direct contact with the debris flows. Because of that, we have a limited understanding of the formation of the debris flows in the upper part of Illgraben, which is inaccessible with direct measurements. To overcome this limitation, the Swiss Federal Institutes WSL and ETH Zurich have been installing a seasonal seismic array since 2017.
Debris flows, when they propagate down the channel, they exert forces on the ground over which they propagate, which generates seismic ground shaking. We can use this ground shaking to locate debris flows both in time and in space, and also to understand better their dynamic properties.
In our recent paper, analyzing bulk flow characteristics of debris flows using their high-frequency seismic signature, by Zhen Zhang et al., we propose a new theoretical model which describes how particles within a debris flow transmit forces as they collide with the ground. We show that not only single particle impacts, but also multi-particle force chain impacts generate seismic ground shaking. Thanks to this theoretical improvement upon previous works, combined with an extensive field calibration, we are able to obtain information on the debris flow properties, such as flow depth and weight, by using seismic data. Our study opens new ways for studying debris flow properties from seismic signals, also in the inaccessible parts of the catchment. Such information is essential for early warning system design, damage reduction, and modeling landscape evolution. If you want to know more details of this study, please have a look at our paper recently published in JGR Solid Earth.